Hey, welcome back to Fat Mama Physics. In this video, we're going to talk about adding rational numbers. Hopefully you know what rational numbers are. So let's quickly begin. Speaking of which, I promised that at the very beginning of every lesson series, I will introduce a new board game, hopefully something that is related to what we are talking about. And today, for this one, I have chosen one of my husband and I's favorite go-to for a short game is called Race for the Galaxy. Race for the Galaxy is good for 2 players and is good for many, but for 2 players is also very fun. And it gives us a sense of going through space in a very short amount of time. So let's switch over to the other video set. Okay, so here we are. This is actually not the base game. This is an expansion. It is one of the later expansions. It's probably the best expansion of all the expansions that have come out. Many of them are not so great. So this one is interesting because what happens is that as you're building a tableau, as you're exploring space and whatnot, you are also trying to defeat these guys called Xenos, and they're these kind of weird alien-looking things, and I'll talk about that in a second. So essentially, this is probably about mid-game to late game, which both players have their tableaus already. I kind of rigged it so it looks really nice for either player, and I'll talk about why in a second, and why this also has to do with adding rational numbers to some degree. So what happens is that as players, every turn, what happens is that, of course, you choose your actions, and every player gets a set of actions that they secretly decide, which can include exploring, for more cards, for planets and people you can consume just to get more money and resources, produce or repair, so produce things on your planets, especially if you have a colored planet. That usually means that it will be able to generate resources for you. So there's settle, so if you settle a different planet. There's develop, so develop technologies, and basically more similar things. So, and consume, okay? So consume for 2 times VP. That's more detail. So let's just focus on kind of the gist of it. Here is maybe a sample tableau. Let's say this is green, and what green would have to do, essentially what happens is every turn you decide some of your actions, you flip them face up, you conduct your actions, and you may actually do the same actions your opponents are doing as well, which is nice because you're trying to guess what they're going to do and try to play accordingly. And after the whole round finishes, then we get these Xenos that come in and invade us. So we get 2 of these guys, and notice it's 1 and 4, which means that 1 is dealt to the weaker player, 4 is dealt to the stronger player in terms of the military strength. Military strength is over here on this track, and to calculate military strength, let's start with green. So military strength appears here. It's a little symbol that beside this, the right over here, which I'm not going to go into what it means, but anyways, it's here, and it's got a red +2, or here, notice it's all in red, and some of them have -1s. Ooh, -1s. There's some other ones here, which I'm not going to go into detail, but maybe I'll talk about. Actually, no, I'm not going to really talk about them. They just mean concrete different specific things. So nothing important. I'm not going to go into that. Okay, so if I count my military tracker, I'm going to count this one, which is +2, +2, which is 4, 5, 6. I don't count this one. I technically count this one, but anyways, it's not nothing too important here. But I would subtract this one. So what was I? I was at 6. -1 is 7. And so I would be at 7 without counting the other special effects, which I'm not going to focus on here. Okay, so notice that the thing when I added this -1, I didn't actually add -1. Actually, I could have. But notice I subtracted 1 instead. So that's the idea when you add rational numbers. You can just add numbers, but if you add, say, a negative number, it's the same thing as subtracting that number from your total, which is kind of what I did. And that's kind of one of the aspects of this game that is related to adding rational numbers. So let's go to purple here. Let's see what purple has. Looks like purple is working off not of a military tableau. He's kind of working on consumption and generating resources and points from that. So let's see. He doesn't actually have a lot of military strength here. Oh, he has a -1. It's not a bad thing because he gets something out of it, which I'm not going to talk about. -1, he has another -1 and whatnot. So you might be thinking, why would any player want to get minus military strength? It has to do with the trade-offs that come with it, which you got to play this game to figure it out. Okay, I'm just kidding. All right, so he has a -2, which means he's going to be the weaker player. So if we're dealt these Xeno cards, then he would have to face this 1 Xeno, and this person here would face this 4. Of course, this person's gonna whip this guy's ass because he's got 7 military strength versus the 4. This guy is in a pinch because he's unable to face off the Xenos with -2. He has to destroy a planet as a consequence. And maybe what he might destroy is he might destroy this Empath world because that way he is... That way he can take away this -1 subtraction. So he can take away that -1 because that planet is gone. He does not take away 1 from his military strength. But at the end of the game, he's going to lose 1 point. So that's up to this guy if he wants to bring this world back to life. Okay, so that's kind of the idea about adding and subtracting rational numbers, because notice that if you have nothing to subtract from, then you just become less than 0. So that's what happened here with the military tracker. So anyways, we played this game until the tableau reaches 12 cards for a single player that marks the last round, or some of the there's some other tokens in the game. When the tokens run out, then that also marks the end of the game. Or if, for example, the players just completely knock the Xenos off the course of the universe or something, then that also marks the end of the game. And we count victory points at the very end, which is marked by these little symbols right beside the world themselves. We count these victory points that are in the hexagons and other point trackers, and that's the end of the game. It's actually very short, very fun, and gives us a sense of going through space. Race for the galaxy. Okay, so back to our lesson. And again, I'm going to divide this video into sections in which I will probably make it through the entire first page. So hopefully we'll be able to do this in 2 videos, okay? And of course, if it gets too long, I will cut it off and say make it a separate part. Let's begin. Okay, adding rational numbers. So, let's do a few examples to begin with. For example, if you're just adding 2 positive numbers, you just become more positive. It's as if you are gaining more money from, let's see, whatever you earn. So, for example, 5 plus 7, this is 12. Okay, nothing too special about that one. But let's say what happens if you're adding a negative number. It's as if you're adding a loan to yourself. But let's say you have, oh, well, here it seems like you already have a loan. So let's say you borrowed $8 from somebody, and you borrow another $5 from someone else. You owe a total of $13. That is designated by this sign over here, -13. So it's as if you're adding those numbers together and slapping the negative sign in front at the end. But what happens if you, say, have a mix? Let's say you have 5 and you have 7, but 5 is positive and 7 is negative. Well, you can think of it this way. Adding a -7, it's almost the same as just subtracting 7 at the end of the game. I'm thinking about games already. So essentially, this is the same as 5 minus 7. So this is kind of like when I was counting my military points, I was counting my numbers, and the circle tells me to -2 or -1, instead of adding the -1 or adding the -2, I just subtracted that number from my total military point score. And you can think of it as this way. Imagine I have $5. Now I take a loan of $7. Essentially what I have to do is I have to pay back the $5, and then I'll have a less loan than I have before. So I'm subtracting 7 from what I already have. So adding a negative is the same thing as subtracting a positive number. So then what happens if I have two numbers I'm subtracting and one is bigger than the other one? Then I kind of think of it as this way. I think of the difference between the two numbers. So I find a difference between the two numbers. I don't care if it's positive or negative. I know the difference between 7 and 5 is just 2. So I just put the 2 in front first. Then I compare, is 5 bigger or is 7 bigger? Since 7 is bigger and 7 is negative, I'm going to put the negative in front. What that means is I have $5. I take a loan of $7. I pay back I use my $5 to pay back the $5 and the $7 loan, and I still have to owe $2 more. So that's what I have left, -2. Okay? So again, the more we practice, the better we're going to get at it. Okay? Seems like I probably will divide this into, actually no, 2 videos is still fine. Example 1, adding rational numbers in fractional form. Okay, so it's now we have to deal with fractions. Okay, so let's see which ones are similar. Okay, so I'm gonna Okay, I'm gonna do A, and I'm gonna do B and D. Okay, so I'm gonna do A, B, and D. And as I'm going along, for C, E, and F, I'm going to ask to pause the video for you to try. Okay? But I'll go over it anyways. Starting with A. Okay, so let's follow the steps here. Number 1, we should always convert mixed fractions to improper fractions first. Like I told us before, improper fractions are more practical to be using them instead. But we don't have a mixed number here, so we don't have to worry about that. So we can just check the first one off. But the next one is if you take a look at these two fractions, we can't add them at this point because they don't have the same denominator. So we have to put them in the same denominator. Reason why is because imagine trying to add halves of pizzas to thirds of pizzas. It's hard to kind of visualize how many wholes you're gonna get. But if you're speaking the same language, if you have them in the same sizes, then you can talk about how many wholes you might have. So finding the common denominator. How to find the common denominator between these two fractions? First of all, let's just set up our page. I'm going to write 2 bars that look like this, meaning I'm going to have a number and a number on the top and a number at the bottom for each. So I'm going to basically rewrite these fractions, okay? First of all, to find the common denominator, look at the 2 denominators. If they're not the same, then the easiest way is to cross multiply, and that for sure is going to give us a common denominator. And so what that looks like is 3 times 5 is going to give us 15. Okay, so I put 15 on the bottom. Then I work backwards and I think, well, how do I get 15 from 3? What do I have to multiply 3 to get 15? Yes, it is 5. So I have to imagine that I'm multiplying the top and the bottom of my fraction by 5 in order to give me the new fraction. I've already multiplied the 3 by the 5 to give me the 15. Next up, I need to multiply the 2 by the 5 to give me 2 times 5 is 10. Okay? The reason why I'm writing it like this is because I have to visualize it so that I'm doing the same thing to the top of my fraction. I'm multiplying the same to the top of my fraction as I am to the bottom of my fraction so that my overall fraction stays the same. The overall value of this number stays the same. And I'm going to do the same thing for 1 over 5. To get 15 from 5, I have to multiply the bottom by 3, which means I also have to multiply the top by 3 as well. So if I multiply by 3, top by 3, I get 1 times 3 is equal to 3. If you don't believe me that these are the same, try and put it into your calculator. So if I take, for example, 2 divided by 3, it gives me 0.666. If I take 10 divided by 15, that is also that's going to give me 0.666. So it doesn't matter if I'm multiplying top and bottom, whatever it is, as long as I multiply them both by the same thing, my overall fraction, my overall value does not change. And that's important for us when we're doing addition here. Okay, now we can add them easily because my answer is going to be in 15ths. Okay, so if I meaning that if I add 15ths of a pizza, I'm still going to get 15ths of a pizza at the end of the day. Then I can just go ahead and add the top. 10 plus 3 is 13. I'm going to have 13 15ths of pizzas at the end. Okay, then check if this answer can be simplified. It cannot be simplified because there's nothing I can divide 13 that I can also divide the 15th by. So that's my final answer. I cannot simplify this anymore. Okay, let's do B together. Okay, again, we don't have a mixed number, so we can just go ahead and work with this one. And hey, guess what? Here, a little bit of shortcut here. Notice that this is exactly like A, except instead of adding 1 over 5, I will be subtracting 1 over 5. So this is exactly the same thing as, since this is the setup is going to be exactly the same, and I'm still adding fractions, I still need to find my common denominator. I might as well just write it exactly what I have before. 10 over 15, and instead of adding 3 over 15, this is a minus. So if I add a negative, this is exactly the same thing as subtracting 1 over 5. So I'm going to subtract 3 over 15. So I have the common denominator, and all I have to do is I keep the bottom the same. If I subtract 15ths from 15ths of a pizza, I'm still going to have 15ths, like the size of this. I'm going to still have the same size of the pizza. 10 minus 3 is 7. 7. Nothing goes into 7, can also go into 15, so that is my final answer. Okay? Well then, hey, look at C. C is using exactly the same fractions as B, but now we're going to subtract. Also, we also have a negative sign in front of the 2 over 3. So good time to pause the video and try this yourself. Okay, I will finish this one up. So, again, we have to make sure they're the common denominator, and we don't have to do this one again because it's the same as the previous question, but I have negative 10 over 15 instead. And since I'm adding a negative, this is exactly the same as subtracting, just like in our previous question, negative 3 over, or subtracting 3 over 15. Well then, we are still going to end up with 15ths of a pizza. Our number is, well, we have negative 10 and negative 3. So if I have negative 10, I subtract negative 3, I'm only going to be more negative. So if I become more negative, this is going to be minus 3. So imagine, so if I have negative 10, I go down 3 again, negative 11, negative 12, negative 13. I get negative 13 over 15, which is my final answer. Okay, and notice it's exactly the same as A, except my answer is negative since both my fractions started out negative to begin with. Okay, here we go. All right, I said I was going to do D and hopefully giving you a chance to try E by yourself. But this time, notice that we have a mixed number. Okay, and that's just one extra step. Everything else is the same. I need to convert my mixed number into an improper fraction first, as said by these instructions. So now I have an extra step in the very beginning. To convert 2 1/6 into an improper fraction, I take the 2, multiply by the 6. Actually, let's write this out first. 2 times 6 gives me 12. Okay, 12 plus 1 gives me 13. 2 times 6 plus 1 over, and I'm going to keep my fraction on the bottom the same. Okay, that doesn't change. If I rewrite this, this is going to give me negative 1 over 4 plus 2 times 6 is 12. 12 plus 1 is 13 over 6. Okay? But right now, we need to make sure that they have the same common denominator. 4 and 6 are not the same numbers. So to find a common denominator here, like I said, the easiest is to do a cross multiply. But if you're super savvy, you can figure out a lowest common denominator just to make your multiplication life easier. So, for example, you can think about, if you remember what the lowest common multiple is, that's what we're kind of looking for right now. What that means is this. If you think about 4 versus 6, let's go up by 4. So if we go by 4, we have 4, 8, 12, 16, 20, 24. And for 6, if we go by 6, we get 12, we get 18, and we get 24. Yes, okay. So 4 times 6 is 24. We could have just used that for a common denominator. But we can choose the lowest common denominator, which then would be the lowest common multiple between the 4 and the 6. So if we compare them, yes, 24 is a match, but we also match with the 12. So 12 is the lowest common denominator. I am going to use that instead to make our multiplication life easier for us. So again, I'm going to set this up as 2 fractions adding to one another. The first one is negative, and I'm going to use 12 as the common denominator again to make our life a little easier. To get the 12 from the 4, I need to multiply it by 3. So I'm going to do the same to the top. 3 times 1 is 3. For the 6, I need to multiply it by 2 to get 12. Same thing I'm going to do to the top. 13 times 2 gives me 26. So here is my ultimate 2 fraction that I'm going to add together. And of course, I'm going to get my final fraction as something out of 12. Now let's add the numerators. So we have 26 and negative 3. So that's the same thing as saying I have 26 minus 3, or I have to add the negative 3 to the 26. Okay, either way, it's the same idea. I take a loan of $3, I have $26 to work with, I pay off the 3, I have 23 left. Okay, so here I have 23. No way to simplify this even more. I'm just going to leave my answer as this. Okay, and again, I don't mind it if you leave it in mixed number form or improper fraction. I almost prefer improper fraction because it is more practical to leave your answer in improper fraction form. Moving on, E, and it's one last step. Okay, doing E, and hey, guess what? I'm going to give you a chance to try this out. Good luck. Pause the video. Okay, so let's do this one together. Again, I'm going to try to convert these ones into improper fraction first. So to convert these into improper fraction, I'm going to have the negative here. 3 times 3 is 9. 9 plus 1 is 10. So 10 over 3, again, this is plus a negative. It's the same thing as subtracting. So I'm going to subtract here. 2 times 6 is 12. 12 plus 5 is 17. Notice I'm kind of doing some of these in my head now, and I still keep it out of 6. I don't change my denominator when I'm converting into improper fraction form. Okay, let's see, double check my math there. Okay, now we can find the common denominator of both of these. So I have this fraction here minus this fraction. Don't forget the negative signs. A lot of people will forget that. So, hey, this is interesting. I have 3 and I have 6. Well then, my common denominator could be 18 if I take 3 times 6. But if I just multiply this 3 by the 2, I get 6. And it will be exactly the same denominator as this other number, which, that's great. Less multiplication to do. So 3 times 2 is going to be 6. 6 is going to be my common denominator. 3 times 2 and 10 times 2 is going to give me 20. I don't even have to do anything to my second fraction because it is already in sixths. That's my common denominator. Then I can add the 2 fractions, or in this case, subtract the 2 fractions. I am also going to have this final fraction over 6 because it's the same size of the pizza. So I have sixths of pizzas. I'm probably going to get a negative number at the end because it looks like I have negative 20 and I have to subtract another 17. It's almost as if I'm adding these 2 numbers and slapping the negative sign in front, which I'm going to do. 20 plus 17 is going to be 30. So that's going to 37. So I'm going to get 37 and negative because both are loans. Both are negatives. Okay, that's my answer. And I don't need to leave it in mixed. I'm not going to require us to leave it in mixed number form. Improper is absolutely fine. Okay, on to the next question. Well, guess what? It looks exactly the same as the previous one. So let's make it a little different so that you get extra practice. I'm going to make that first number there positive. So you have a positive number instead of a negative number to work with. That's going to change your answer, okay? Now is a good time to pause the video and try F. Well, if you had thought, hey, aren't these the same numbers as before? Then absolutely. Let's just rewrite them because they're exactly the same number, except the first number is not a negative. And the second number is the same, so I'm going to subtract 2/5, exactly the same number. So I'm just going to write negative 17 over 6, exactly the same as the previous question. Very nice. And guess what? We don't even have to, you didn't have to do this one yourself. We can just write the common denominator fractions right below. This is 20 over 6, no negative sign, minus 17 over 6, very exactly much the same. And all you needed to do is just do a subtraction. Oh, this is even a very nice subtraction. 20 minus 17, that's so nice. That's just 3. Hey, guess what? This fraction you can simplify. So you're not done here. We can simplify this. Simply divide the top and the bottom by the same number to make sure it's in simple form. We can divide top and bottom by 3, so this goes in nicely. 3 divided by 3 is 1, and 6 divided by 3 is 2. This is exactly a half, so that's your final answer. When you do a quiz or a test, make sure all your answers are in the most simple form, because you could lose marks in communication, whatnot. Okay, here you go. You know what? I'm gonna stop the video. I'm gonna put example 2 in the next video. So thank you very much for watching. Whoa, that's a long video. Thank you very much for watching. Good luck with your practice. Fab Mama Physics signing out.